Assalamu alaikum. In this video, let's look about what is this carbon-14 dating. Carbon-14 dating, this is a method used to estimate the old ancient time animals, mummies, or any living organism that we can estimate at what period they lived. So here, to understand how carbon-14 dating works, first we will have to go up to the atmosphere, to the outer atmosphere. In the outer atmosphere, we have something called the cosmic rays. From its name, rays, don't think they are waves, but they are not waves, they are actually particles, high energy particles that are released from sun or stars and similar. Okay, so these cosmic rays are high energy particles like protons, neutrons, and other atomic nuclei, or it can contain any. And when these particles collide with atoms, they collide with atoms in the upper atmosphere, upper outer atmosphere. They will release other particles. They will release a lot of particles, but we are only interested in high energy neutron. So when cosmic rays collide with atoms in the outer nucleus or the upper nucleus, they might release a lot of other particles, but we are only interested in high energy neutron. So, this high energy neutron, it might collide with a lot of atomic nuclei in the atmosphere, but we are only interested when it collides with nitrogen 14. When it collides with nitrogen 14, so it's a fast moving neutron. Neutron has mass number 1, charge number 0. The reaction will be like this neutron, when collide with the nucleus of nitrogen, when it collide with the nucleus of nitrogen, what it does is it replaces a proton. It will send off a proton out and it will take the place of that proton. So during this reaction, a proton is released. If a proton is released and a neutron replaces its place, the atomic mass won't change. Therefore, it will remain as 14, but a charge will reduce. Therefore, it becomes carbon. And as I mentioned, it replaces a proton, right? So a proton is emitted. Now, uh, this is the reaction that is going to occur due to this fast moving neutron. We get carbon-14. Carbon-14 is an isotope of carbon which is radioactive. So carbon-14 is radioactive. And this carbon-14 with time it undergoes beta decay. It undergoes beta decay to turn back into nitrogen. Nitrogen 14. It turns back into nitrogen 14. So let's look at this reaction. Carbon 14, it releases or undergoes beta minus decay, right? During that, it releases electron. So from the nucleus, in the nucleus, we have six neutrons, sorry, six protons, and eight neutrons, eight neutrons. So from where does this electron particle get released? Electron particle is released from one of these neutrons. So the neutron is neutron is neutral. When it releases an electron, now it becomes positively charged. Therefore, this converts into proton. So the number of proton becomes 7 and number of neutron also becomes 7. That is nitrogen. So this turns into nitrogen 14 7. During this, it releases a beta particle, a beta minus particle. So what is the charge? Minus 1, and its mass is 0. And we know during a beta emission, we always have a neutrino emission. But here it's beta minus, therefore it is going to be antineutrino. So in the previous video, I mentioned this antineutrino is released for the conservation of momentum and the conservation of energy. Without this particle, this reaction will uh, not obey these two conditions. That is why it was introduced and later it was proved there is a particle. So when the high energy neutron collide with nitrogen 14, the following reaction takes place. We discussed. Carbon-14 is radioactive. This subsequently decay to form nitrogen-14 by emitting beta minus particle. We have gone through this equation also. Now let's look what will happen next. So this reaction, carbon-14 turning back into nitrogen-14, it will take ten thousands of years. It will take a very long time. It will take a very long time. Therefore, uh, before that, before turning into nitrogen 14, a lot of reaction will occur. For example, this carbon 14 will react with oxygen and form carbon dioxide. So this carbon dioxide, it is CO2. Here let's denote as 14. So it's the carbon dioxide due to carbon 14. And this carbon 14 is also absorbed by plants because there is no selective absorption. It will absorb carbon dioxide. It could be carbon 12 carbon dioxide or carbon 14 carbon dioxide. So plants absorb, and the other organisms consumes plants. They consume plants. Therefore, they get carbon 14 from plants. There is no any other way because organisms don't take in carbon dioxide. And this is an important point, how animals gain carbon dioxide, that is carbon 14, that is very important. Next, the ratio carbon 14 is to carbon 12 ratio. This ratio has been a constant for a very, very long period. It has been constant for a very, very long period. Therefore, we can assume there is no significant change. Actually, there is no significant change in this ratio for a very long period of time. Thus, we assume it to be a constant. So, the second important assumption is this. The second important point is this. That's the first assumption. Now, let's look. When an organism dies, there is no fresh intake of C14 because organisms intake C14 only from plants. But soon as they die, they are not going to consume C14. They are not going to consume plants. Therefore, there is no consumption of C14. So this C14 starts to decay. If C14 starts to decay, the ratio of C14 is to C12 in organisms is going to decrease because C12 is constant, C14 reduces, therefore the ratio reduces. And if we look at the half-life of C14, it is almost 5730 years. So, by measuring the radioactivity today at the current situation, we can estimate the age. We can estimate the age of that carbon containing material. Hope the idea is clear. Let's look one example, then you will understand the idea much clearer. So, a mummy of a pharaoh in Egypt is found to have 3.21 into 10 to the power 10 atoms of C14 per gram of carbon. So, they have given us the ratio. C14 is to C12 is 3.21 into 10 to the power 10 gram, sorry, number of atoms. So there is this amount of carbon, so it's directly the number per kilogram. Okay, so if we consider 1 gram of C12, in that this amount, number, not in mass, this number of carbon 14 is present. That's the idea. So according to that information, they have given what is the current amount of C14. What is the current amount of C14? And they say if the initial amount of C14 was 5.02 into 10 to the power 10 per gram carbon. So, according to the nature, it should have had the ratio of 5.02 into 10 to the power 10 gram, sorry, number of C14 for a gram of carbon. Here, a gram of carbon in the sense it contains C14 and C12. Okay, this contains C14 and C12. Together only we say carbon. So if you have 1 gram of carbon, that is going to have this amount of C14. Now we have to estimate the time he lived. The half-life of carbon is given. So let's see how we can do this question. We know that Nt is equal N naught E minus lambda T. So Nt over N naught is equal to this. Now let's take ln on either sides. That's the normal logarithm with base E. When we do that, we get Nt over N naught is equal E minus lambda T. Now take ln on either sides, then we have ln N over N naught is equal, you can take this index on front, minus lambda T ln E. So ln E is going to be equal to 1. This is 1. Now we have uh, ln ln N over N naught over lambda. Over lambda is equal, minus lambda is equal to T. So we have got an important equation. Here we can find what is ln N over N naught, because N and N naught is given. Therefore, we have to just get what is ln. Next, what is this lambda? We already obtained an equation for lambda, right? Can you remember that T half-life is ln 2 over lambda. So lambda is ln 2 over T half-life. So from that, uh, instead of lambda, so T is equal minus ln n over n naught over lambda, right? Instead of lambda, we can write ln 2 into T half. ln 2 into T half. Now, let's apply the values and see. I can get rid of this minus 1. We have minus 1 in front, right? Let's take minus 1 into this. Then we get ln n over n naught to the power minus 1. Just flip the side. So ln n naught over n over ln 2 into t to the power half. So t is equal ln ln. We have n naught over n. So n naught is 5.02 divided by 3.21, because 10 to the power 10 gets cancelled, and we have to get the ln of this divided by ln2 is 0.693 into the t half life that was given as 5730. So when we calculate, we get 3697. So I will consider it as 3700. Okay, 3697. Okay, so here it is 3697 years ago. Now let's say now year is 2013. So from 2013, if we deduct 2013, then we get 4861. So that's around 1648 BCE. So here you are not going to get question up to this level in our exams, but for you to understand what's this C14 dating, carbon 14 dating, if you go through this question properly, you will get the idea why we do this and how we do this. Okay, so here these simplification and all, just go through my simplification and check. Other than that, what you have to understand is the process. To understand the process, we need a question, we need an example. That is what I have done for you. You are not going to get these types of question. I hope you have got a clear idea. If not, make sure you can ask. Okay. Assalamu alaikum.